Good morning, everybody, and welcome to our new chapter, Number Theory, and it's topic 12. Now, Miss Campbell's class has done this, but Miss Walker left it because we had been doing it every day, really, nearly every day through the New Wave, and because I spent a lot of time in New Wave, they were kind of little class lessons in themselves. And guys, really and truly, when you go through this, most of this chapter, you'll understand why I left it till now. Just it's more or less revision rather than teaching. So if we go to B, I want you to concentrate on 3 to 8 and answer those questions. So you're answering about odd numbers, even numbers, how many numbers, what are the numbers that you can be divided by 2 with no remainder. All odd numbers end in whatever, even numbers end in whatever, and then there's always a remainder of something when you divide by an odd number by 2. That's number 6. So you do 3 to 8 and the answers will be uploaded for you tomorrow. Very, very, very doable. Then fill in the missing word, odd or even. Make up a number sentence to show your answer. The number sentence is like this: 3 plus 8, 4 plus 5, blah, blah, blah. And it's really reinforcing the whole idea that odd plus odd is even. And then even plus something is odd. So by doing the 12 of these, it'll, you'll really come to understand what you get when you add an odd and an odd number together, an even and an even number together, and an even and an odd number together. And then you use, you must show your results using a number sentence, such as in the first one, 3 plus 5 is 8. 3 plus 5 is equal to 8, yeah. So factors and products. A factor is a whole number that divides into another number evenly with no remainder. Now, I'll be saying that forever, Miss Campbell and I. Pairs of factors have a product, for example, 6 by 2. 6 by 2, the product of 6 by 2, 8. Or the product of 6 by 2, 12. Mary, learn your tables. So guys, I was adding it in my head. If you get that, guys, then you can do 1, 2, and 3. So just the product of any number is one number multiplied by another. Okay, and the answer you get is the product of those two. Right, so you're going to do all of the ones B, 3 to 8, all of C, very easy, and D, please. And that is a good bit of revision for number theory. Then we'll go to the revision sheets, the revision sheet answers for the sums on Friday. And this is a revision of dividing by decimals, dividing using where decimals are involved. So 10 times smaller, 100 times smaller, and 1,000 times smaller. So what I said on Friday was, when you're dividing by making something 10 times smaller, you're making each digit, you're decreasing it times 10. So, for example, the 1 unit will become 1/10, and the 2/10 will become 2/100. So look at the way, guys, it looks like you've moved your decimal point one place to the left, doesn't it? The 1.2 becomes 0.12, but in actual fact, you're making the numbers 10 times smaller. So you're moving each digit one place to the right, because when you're moving to the right on the number line, you're getting smaller, and to the left. Remember again, you have your decimal point to the left of the decimal point, units, tens, hundreds, thousands, tens of thousands, etc. Then to the right of the decimal point, you have tenths, you have hundreds, you have thousands. So as you keep going, you know you're getting smaller. So that is, but the trick is to bear in mind that, to make it easy for you, just think that it looks like, it appears that the decimal point is moving to the left, one place to the left when you're making it 10 times smaller, but it's not. But if you just use that as a trick, once you understand that it's not the decimal point stays in place, it's the digits that move. If they increase, the digits move to the left, one place to the left, multiply by 10, 2 places to the left, multiply by 100, 3 places to the left, multiply by 1,000, and then making it smaller, one place to the right, the digit moves one place to the right when you're making it smaller by 10. 2 places to the right when you're making it smaller times 100, and 3 places to the right when you're making it smaller times 1,000. But once you understand that, you can just use the trick whereby it looks like the decimal place is moving. Okay, it looks like the decimal place is moving one place to the left when you're multiplying, when you're making it 10 times smaller. 2 places to the left when you're multiplying, making it 10 times, when you're making it 100 times smaller, and then 3 places to the left when you're making it 1,000 times smaller. So 1.2 becomes 0.12. So it looks like the decimal point moved one place to the left, but we know it wasn't. It was the digits. In fact, the digits were moving one place to the right, because they were getting 10 times smaller. Then in 666.85, again, if you move the decimal point one place to the left, it becomes 66.685. But that's not really what happened. That's the trick. What really happened was every digit there moved one place to the right because it was decreased times by 10 times. And then 133.3, again, this looks like it's moving one place to the left, the decimal point, but in actual fact, the decimal point remains stationary, and the numbers, the digits, are decreased times 10, so they move one place to the right. Every single digit becomes 10 times smaller. You must understand that, guys. 0.05, again, it looks like the decimal point moved one place to the left, as in 0.045, but it wasn't. It was, in fact, each number, each digit was being decreased times 10. Now we move over to 100 and 4.3. Again, this time you're moving the decimal point. It looks like you're moving the decimal point two places to the left, because this time you're decreasing it not times 10, you're decreasing it times 100. So every digit will be moving 2 places to the right when you're decreasing by 100. So it looks like the decimal point is moving 2 places to the left, but we know that that's not true. The decimal point remains in place. Okay, so that's 7.96, that becomes 0.0796. 40.3 becomes 0.403. Again, the decimal point appears like it's moving 2 places to the left, but it's the digits moving to the right. Times 100, so two places. And then again, 110.4, that becomes 1.104. Again, the decimal point looks like it's moving 2 places to the left, but it's the numbers moving 2 places to the right, each digit. Then 1,250 becomes 0.250, and 1 becomes 0.001. Again, remember the digits. This time they'll be moving 3 places to the right, so it looks like the decimal point is itself moving 3 places to the left. Okay, but we know the decimal point remains in place. It's all, the action is done to the numbers, to each digit, not the decimal point. And then 1, it looks like the decimal point is 0.001. And in fact, we know that 1 is being moved 3 places to the right because it's becoming 1,000 times smaller. And then 1,050 becomes 1.050, and 46 becomes 0.046. QD. Just remember, guys, the trick is move your decimal point. But once you know that you're not actually moving your decimal point, it's just perceived that in that manner. But you know the reasoning behind it, that each digit is becoming X times smaller, 10 times smaller, or 100 times smaller, 1,000 times smaller. 10 times smaller, you move it 1 place to the right. 100 times smaller, 2 places to the right. 1,000 times smaller, 3 places to the right. And then the opposite for multiplication, moving 1 place to the left. Your numbers get greater times moving 2 places to the right when you're multiplying by 100, and 1,000 multiplying by 1,000. Each digit is moving 3 places to the left. Each digit, not one of the digits, each of the digits listed. Your decimal point remains intact. It remains stationary. Everything else moves around it, but it's just a trick that we use to make it easier for us just to get it done quickly. Okay, that's the trick. It is not the reasoning behind it. Now we're going to go on to number 2 tonight, and I'm going to get you to do 2 and 3 tonight. Round each decimal to the nearest whole number. Okay, so nearest whole number. The decimal 107.7, I want you to round it to the nearest whole number. Whole number, guys, not decimal number. And then estimate first, and then THEN, that should be do long division. So PS, in estimation, you are rounding to the nearest 10. Okay, in the estimation, you round to the nearest 10. So you have to round 23.4 to the nearest 10 and 18 to the nearest 10. Just not one of the numbers. You round the 2 parts of A, the 2 parts of B. 139.2, round to the nearest 10, round 58 to the nearest 10. And the same for C. And the answers will be uploaded for you tomorrow, guys. So the best of luck with that. And we'll talk to you in the morning, please God, when we'll be continuing with number theory. And then we'll be doing 4 and 5 here. Okay. And the answers again, I'll go through them in the class lesson, and they'll be uploaded as answers as a JPEG. Okay, talk to you tomorrow, guys. Bye.